and welcome. This is Introduction to Basic Principles of Chemistry, and I know what you're thinking. I am excited to be learning all about chemistry because your entire life you have thought to yourself, how can I learn more about the natural world around me? Now, let's be honest. Chances are you're here because it was the next course you had to take, right? But hopefully, as you watch some of this video series and as you kind of start your own journey into the chemical universe, we're going to figure out some stuff and we're going to learn some stuff. We're going to see some stuff that's kind of neat and kind of cool. And it might just give you a new perspective on our great universe and our great world all around us. So without further ado, we're going to jump right into this. And we're going to start off with the most basic and rudimentary of ideas, which is, what is chemistry? And yes, I know, I apologize. It's the study of matter. Really, it's all things matter related. And so when we talk about matter, everyone's always like, well, how do we define matter? What is matter, et cetera, et cetera. Before we jump into that, what I want to do is I want to talk a little bit about, as I mentioned earlier, our universe. Because you see, our universe can actually be broken up into two distinctive parts. We can say that our universe is made up of energy, and energy is over here, and our universe is made up of matter, right? Now, we're going to see later on that these two, worlds are actually more interlinked than we would like to believe, right? And probably than what we originally learned. But for now, we're going to keep them separated, right? It'll be easier to kind of work with them from that perspective. And so what we're going to do is that we'll talk more about energy later on, but just as a quick primary review, right? Energy is anything that we use to describe in terms of the ability to do work. And that's a real hokey definition. We'll break that down later on too. But for now, let's keep it simple and say that energy, when we're dealing with it in chemistry, is usually going to be referred to by the velocity, how fast energy is moving in terms of like the speed of light. We're going to be really concerned with electromagnetic radiation. We're going to be looking at things like its wavelength and its frequency, and all of that is cute and great. We're going to put that off to the side, but here's the big kicker, what you want to take away from all of this. When we talk about energy, we're almost always going to measure energy in terms of joules. That's the unit of measurement that we use when describing energy. Now, that's all well and good, but like I said, this isn't a course on energy. This is chemistry, the study of matter. So when we look at this idea of matter, what I'm going to do is I'm going to usually refer to it as something that we can measure using one of our five senses. And again, a little hokey, a little generic and basic. But what I mean by that is that matter is usually the stuff that you can touch, you can feel it, you can see it, you can observe it. You can bang on something and you can hear how it sounds, right? So all of those are ways to describe matter, right? So again, we can do things like measure the mass of an object, right? You can only measure mass if it's matter. How something tastes, you're actually tasting chemicals and whatnot. So again, matter, particles, right? How it feels, the volume, the color. And when we talk about matter, there's going to be a lot of units that we can use to describe it. So if I want to describe the amount of mass in an object, I might use something like grams. If I want to talk about how much volume does it occupy, I might use liters, right? We're going to see this unit later on, this one over here, but if we want to talk about something like how much stuff do we have, right? The amount of stuff that we have is called a mole of stuff. Again, we'll see it more later on. But just the takeaway is that when we talk about matter, it's going to have various units associated with it. And usually, not always, but usually, it's something that's dealing off of one of our five senses. Now, the big question then is, what on earth is matter? So here's the real sciencey, heavy definition. Matter, at the end of the day, is the amount of stuff, and let me say stuff in air quotes, the amount of stuff that makes up an object, right? Now, how we describe that stuff, well, welcome to chemistry, right? We're going to spend some time talking about that, right? But when I say things like stuff, what I usually am referring to is this idea of stuff can be broken down into two different things, pure substances and mixtures. right? And this is actually things that you've probably heard of. What I mean by that is if you recall, right, probably in middle school or elementary school, you heard of a pure substance, because a pure substance is a substance that cannot be broken down into simpler, smaller pieces. And here's the kicker, without permanently, right, without permanently altering what that substance is. Right? So if you break down a pure substance, it's going to become something else. It will no longer be what you originally started off with, right? And the other thing that makes up our stuff is known as a mixture. And a mixture is basically two or more pure substances that are literally physically placed. Here's object one, here's object two, and they're just literally placed next to one another. They're not bound, they're not stuck together, they're not, there's no chemical interaction between them. They're literally just placed one next to the other. Our big fancy word will be they're juxtaposed, right? So they're just literally placed, they're stuck next to one another. Okay? So this is when we talk about stuff, pure substances, and mixtures. Now, what are some pure substances that you've probably heard of before, right? Well, you've probably heard of this idea of an element, right? And you've probably also heard of this idea known as a compound, right? With mixtures, there's two types. We have homogeneous, sometimes referred to as homogeneous, tomato, tomato, and heterogeneous. Okay, now these are the words that I'm going to be defining next because, again, these are those important terms that we're going to be using all the time and you want to make sure you have an understanding of it. Now, the good news is most people, as soon as you say elements or compounds, boom, they immediately can think of a bunch of definitions for it because this is what most of us grew up talking about, thinking about. In the Magic School Bus, this is what they referred to all the time. So an element is comprised of a single atom. Right? That atom has all the characteristics of that element. Okay, has all the characteristics of that element. So in theory, if I had a bar of gold and I could tell you that the bar of gold had a certain melting point and it had a certain color, right, and it had a certain electrical conductivity, if I took a singular atom of that bar of gold, all those things would still be true. It would, in theory, if I could see it, have the same color, right? It would have the same electrical conductivity. It would have the same chemical properties as the bar of gold, right? Now, can an atom be split? The answer is yes. But, and here's the big but, right? If you split an atom, you no longer have the element gold. You've created something else. So elements are made up of single atoms, right, where that atom has all of the characteristics of that particular element. If you break and split that atom up, then you have forever altered the element in question. Okay, so that's you've made something else now, right? We no longer have that element. Our next term, right, is this idea of a compound, right? And a compound is going to be made up of two or more chemically bonded atoms. Okay, so I'm going to use the simplest one that we're all familiar with, right? We've all heard of water, H2O, right? Right, so water is a compound. It is made up of two elements. On one side you have hydrogen, and on the other side you have oxygen, right? So what happens is that when I look at water molecules, right, water molecules, every single water molecule is going to look like this, 2 hydrogens for every 1 oxygen, right? 2 to 1, 2 to 1, 2 to 1. We're going to be playing with ratios a lot, all right? So when we look at a water molecule, that 2 to 1 ratio holds, and in theory, every single water molecule, it doesn't matter how much you have, will always have this exact same ratio, right? And can we break a compound up? Can we break a molecule up? The answer is yes, but, again, big but, if you do, you break it up into the individual elements and you no longer have the compound. So I can split the water molecule up, but when I do, I now have hydrogen and I have oxygen and it no longer behaves like water, okay? Now, another possibility is that if we have mixtures, there's 2 types of mixtures. You have homogeneous mixtures, that's where you have different substances that are evenly mixed throughout, right? And the big kicker is that there are no visible boundaries, right? There's no visible boundaries. So an example of a homogeneous mixture that I always use is something like, look at cement. How do we make cement? Well, we took sand and we took rock and we took dirt and we took all this stuff. We mix it together, but when I pour it, it looks like I have a white slab, and I have a really tough time discerning, like, well, where is the sand versus the dirt versus the rock versus whatever the case might be, right? The water that was in there. So if I cannot see boundaries, even though they're made up of different substances, we say it's a homogeneous mixture. Another good example of a homogeneous mixture is salt water. I take some salt, I put it into water, I stir it up. I can no longer see where is the salt particle and where is the water particle. To me, it's completely evenly distributed throughout. Okay, so this is my homogeneous mixture, right? And then finally, we're going to talk about our heterogeneous mixtures. And so in a heterogeneous mixtures, we have two substances, two pure substances that are now unevenly mixed throughout, right? And I say unevenly because what will occur in a heterogeneous mixture is that you will see a boundary, right? So think of something like a pepperoni pizza, right? You can see where the cheese is and where the pepperoni is, right? So if this is my pepperoni here and this is all my cheese here, I can see a boundary between the two of them, right? You could also say something like, if you had a mixture of, let's say, sand and water, you should be able to visibly see that boundary of the water's up here and the sand is below it, right? So anytime you see a boundary, that's an example of a heterogeneous mixture. The last example I like to use a lot of times is like I really like vanilla bean ice cream. And so when you look at vanilla ice cream, especially vanilla bean, you'll notice that there's these little black specks in it, right? Teeny tiny little black specks. And everyone always looks at vanilla ice cream and they're like, oh, it's homogeneous. And I go, wait a second. If it were homogeneous, it would look the same throughout. Can you identify when you're looking at this, can you see a black speck? And if the answer is yes, then you, my friend, have noticed a visible boundary, and as a result, that is a heterogeneous mixture. So we take it one step at a time, one tick at a talk, and you'll be there in virtually no time.